Hi guys, we have lesson 14 on double replacement reactions next. So once you've done single replacement, double replacement is pretty easy because we've got two ionic compounds reacting in double replacement. So usually it's two liquids that we're going to put together. And then what happens is you always see the metals switching places. So you don't have to determine whether it's the metals or non-metals like in single replacement. You just have to assume that the metals are always switching places. So the first thing in each compound is going to switch. So these ones you have to write a lot of ionic compounds. So make sure that you really understand how to do that for this lesson. All right, jumping right into it, we have lead 2 nitrate and sodium iodide that are reacted in a test tube, and what we get after is lead 2 iodide and sodium nitrate. Pause the video and look up the charges for all of those elements. So hopefully you found charges for all of these to be 2 plus for lead 2. Nitrate is a polyatomic. It's NO3 up in the box on the periodic table, and it has a charge of -1. Sodium has a charge of +1, and iodide has a charge of -1. Once the charges are written, we'll go ahead and we'll cross the charges if we need to and write the chemical formulas. So lead 2 nitrate, the charges are not balanced. 2 plus and -1 do not balance. So with lead and nitrate, which is NO3, I'm going to cross that 2 to be behind nitrate. And of course, the secret 1 is behind lead, but I don't need to write that. I'm leaving a little space so that I can look up solubilities in a moment. Sodium and iodide, the charges balance, plus and minus. So I'm simply going to write sodium followed by iodide. Lead 2 iodide. Lead, iodide, cross the charge. Sodium nitrate balances, so simply write sodium followed by nitrate. Now pause the video again and look up your solubilities. The solubilities for nitrate are going to be most elements aqueous unless it's the 3 elements listed below. So I'm looking at this page of the data booklet. Here I found nitrate. Most elements are aqueous, except for these 3 listed below, which make a solid. We don't have these 3 being created, so we're going to go with aqueous for both of our nitrate solutions. This one and this one. Next, I'm going to look up iodine, which is right here. Most elements form aqueous solutions except for copper 1, silver, lead 2, and thallium. So unless we have these 4, we're going to write aqueous. Oh, here's lead 2. This is when you do get a solid. What we call this solid in the test tube when it forms is a precipitate. It basically looks like cloudy little bits floating in the aqueous solution or little solid chunks that are visible. Now I'm going to balance this, so go ahead and pause the video and try that on your own. So the solution for balancing this is to take a look at how many nitrates I have, which is 2, and I'm going to make 2 over here. I then change to 2 sodium. So here I'm going to make 2 sodium, which also changed to 2 iodine, but I already had 2 iodine. Are my lead terms balanced? 1 and 1? Yes, they are. So you can put secret 1s to show that that's balanced. Question B. Aqueous copper 1 nitrate and aqueous potassium bromide are mixed. A precipitate of solid copper 1 bromide and blank is formed. So what we have to figure out is what's going to form. So you can see that copper bromide is the first product. It came from copper here and bromide here. So what is also going to form is the other two, the nitrate and the potassium. The way that we write ionic compounds is we always write the metal first, so potassium, and then the nitrate. Now that we have the words written, we can write the charges and we can write the chemical formulas by crossing the charges. Copper 1 means 1 plus. Nitrate we worked with up here, so I'm just going to borrow the charge. I've already looked it up. Potassium is +1. And bromide is -1. So this is a really nice question. Not only do they tell us the states, but it's also all charges of 1 and -1. They all balance, so you're simply writing the chemical formulas for each of these. So the first one is aqueous copper 1 nitrate, copper, nitrate, aqueous. Then we have aqueous potassium bromide, potassium, bromide, aqueous. A precipitate of solid copper 1 bromide is formed, and also potassium nitrate, which I'm going to look up because that's the one thing we don't know solubility for, but nitrate is mostly aqueous except for 3 compounds, which we don't have, so aqueous. Now, the order that you write these doesn't matter. You could write what you're adding on this side of the equation in the reverse order. It doesn't matter as long as you have all of the right things. So I'm going to go through and I'm going to start balancing now. I don't see any numbers on subscripts on any of these. So I think most of this is probably balanced. I'm going to start with the most complicated thing I see, which is nitrate. I see 1 nitrate on either side. I see 1 copper on either side, 1 potassium, and 1 bromine. This is completely balanced as is. Doesn't happen that way very often, but that's a nice question where the balancing is already done for you. Try to balance this question on your own, pause the video, and come back for the solution. The solution to this one has 3 chlorine, making 3 chlorine. 3 sodium makes 3 sodium. 3 iodine matches with 3 iodine. And 1 aluminum matches with 1 aluminum. For an extra challenge, I'd like you to pause the video and try and write this chemical reaction out in words. Try and be as scientifically accurate with your terminology as you can. Try to use words like solid, precipitate, aqueous, solution, double replacement reaction, ionic compounds, anything that you can think of that we've used in this unit that applies to this question. Here's my example of the words that you might see describing this chemical reaction. So here's one example of what the words could say. So an aqueous solution of sodium iodide is mixed with an aqueous solution of aluminum chloride to produce aqueous sodium chloride and a precipitate of aluminum iodide. So I used that word precipitate that tells us that aluminum iodide in the reaction creates a solid. I used aqueous or the word solution to describe all of the aqueous elements here. And I've used the proper way of writing ionic compounds by stating all of the metals first, then the nonmetals, where the ending changes to IDE. One last example, try to do this one on your own and then restart the video here to see the solution. Here's my solution to example D. We have aqueous lead-2 nitrate. Lead-2 will always have a charge of 2 plus, and nitrate, or NO3, has a charge of -1. It's mixed with aqueous sodium iodide. Sodium is plus, and iodide is minus. Now I see two ionic compounds, so I know this is double replacement. I'm going to take the metals, and I'm going to switch them. That's going to tell me what this makes. This is going to make lead-2 iodide and sodium nitrate. So you can see that the lead-2 mixed with the iodide and the sodium mixed with the nitrate, literally just switching places. Now that I have my words written out, I can write all of the charges on top. They haven't changed, even though they've rearranged themselves, they're still the same charges. And now I can write with my chemical formulas what this is going to look like. Lead and nitrate crossing the charge of 2 over, and they've told me that's an aqueous solution. Sodium iodide, charge is already balanced, aqueous. Lead iodide, cross the 2 over, and sodium nitrate. We've done sodium nitrate before, so I remember that it's aqueous, but I'm going to look up lead-2 iodide and see if it's on my solubility table. Iodide is right here on the solubility table, and it says that copper 1, silver, lead 2, and thallium all make solids or precipitates. We have lead-2 in our question, so I'm going to write a solid behind it. So that would show up as little chunks of solid material in the test tube when you mix them together. Now I'm going to balance. So pause the video so you can check your answer with mine. I'm starting with the most complicated thing I see, which is nitrate. I see 2 nitrates and 1 nitrate. I'm going to make 2 on the product side. I just made 2 sodiums, so I'm going to go back to the reactant side and make sure there's 2 sodiums. I just made 2 iodines. I have 2 iodines. I have 1 lead. I have 1 lead. This reaction is a double replacement reaction, and it's now completely balanced. Again, you can make sure that everything balances by doing a list of all of your elements that you have on the reactant and the product side. And then just counting. How many leads do you see on the reactants? 1. How many NO3s? 2. I see 2 sodium and 2 iodine. Does it match with this side? I see 1 lead. I see 2 NO3s, 2 sodium, and 2 iodine. So since these balance, This question is completely right. The section in the practice booklet on lesson 14, double replacement reactions, is due for next week. Let me know if you need any help.